So in this problem, the relationship is the height of an object versus time. So as something falls, we know that it's going to be speeding up as it falls. So we're going to have the height is based on how long something's been falling for. And we would expect this falling object to kind of follow an arc. Okay, and that arc is actually called a parabola. So there's our relationship. Okay, in words we have it, and here's our equation. And when we're talking about something's dependent on time, so the height is dependent on time, so the height should be our y, or our output, and time should be our x, or our input. Okay. So when we talk about time, we usually should think about 0 time. So where does it start? Well, the sentence tells us it starts at 100 meters. If we plug in time into our equation, we get the same thing, so we can do that as well. Now, because of the calculation here, we probably should use a calculator because it's not a straightforward calculation. But I want to find out where it is at maybe 1 second. So at 1 second, we're at 95.1 meters. Okay, at 2 seconds, it's going to be 100 minus 4.9 times 2 squared. Okay, so it's 4.9 times 2 squared. Okay, I get 80.4. Okay, and I'm going to jump to maybe like 4 seconds. Yeah, 4 seconds. 100 minus 4.9 times 4 squared gives me 21.6 meters. And I'm going to go to maybe 5 seconds. It's pretty much going to hit the ground in 5 seconds, it looks like. Yeah, in fact, it's gone through the ground and it's at negative 22.5. So I don't know if we should use that last coordinate or not. So I'm going to scale my axes here. So I need to fit 100 meters into here. So I'm going to go maybe 10, 20, 30, 40, 50, 60, 70, 80. Oh, that doesn't quite fit. So I'm going to go up by 1. So 20, 40, 60, 80, 100. So there's my 100 meters here, and there's my starting point. Okay, and then after 1 second, and I'm going to maybe scale my axis here, after 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. So after 1 second, I'm at 95.1. So it didn't fall very far. After 2 seconds, it's gone to about 80. Okay, so 80.4. After 4 seconds, it's fallen quite a bit down to 21. Okay, and after 5 seconds, it looks like it's going to go through the ground. So the pattern is going to be this pattern. It's going to fall along this arc. And this arc looks like this. And it looks like it hits the ground maybe around 4.5 seconds. We can plug in 4.5 and see if that's going to be a height of 0. And that would indicate when it hit the ground. So what is the dependent variable? Well, the height is dependent on the time. So the height is our dependent variable. That makes the time the independent variable. And if you're not sure, generally time is independent because most things depend on time. In function notation, I should write like this. F of x, my output, is equal to we start with 100 meters. And then we're going to take away 4.9 times the time squared. So there's my function notation. Actually, it's going to be my x squared, unless I want to change this to x.